I'm looking at this trig expression. I'm very suspicious of this squared trig function, this plus or minus 1, and immediately makes me think of this Pythagorean identity. But of course, over here I have secant squared x minus 1. This says tangent squared plus 1 equals secant squared. But with a little bit of algebra, if I subtract 1 from both sides, I can clearly see that tangent squared x equals secant squared x minus 1. So this expression can be replaced with tangent squared x over sine squared x. Because we can rewrite tangent in terms of sines and cosines, there probably is a little bit more work we can do to get rid of some more trig functions, or at the very least get this out of the denominator. Something can happen. Everyone, I think, knows that tangent is sine over cosine. And we have a couple of choices here. So one thing we can do is think about this expression as being the tangent squared of x times 1 over sine squared x. This is the long way to do things. So I'm going to show you this long way one time, and then I'm going to show you a shortcut that might be helpful. But if you don't like the shortcut, then you can always take a fraction like this and break it up with the numerator times 1 over the denominator. Thinking about this tangent as being sine over cosine, and of course this is still 1 over sine squared x, we can see that these guys will cross cancel, leaving us with 1 over cosine squared x, which I can now use a reciprocal identity to write the final answer as secant squared x. That's the best answer because it's just one trig function, there's no denominators, and I'm pretty happy. Now, one thing you might consider that, if it occurs to you, it can be a little bit faster, is if I see an expression like this, and I know I'm going to think of tangent as being sine over cosine, and I've already got denominators going on, I can think of this as this is just going to go into this denominator, and then this is going to stay in the numerator. So tangent squared could be thought of as sine squared x over cosine squared x in the denominator, and this sine squared is still in the denominator, and then these cancel, getting me to the same place. I'm not even necessarily sure that it's faster to do it that way, but I definitely want you guys to be aware of this idea that you can take something like this where it's a fraction, and when you write the fraction, you can put the denominator in the denominator that already exists, as opposed to adding all this other algebraic manipulation. It's up to you. But at the end of the day, we want to have secant squared x as our final answer because it's one trig function, there's no denominators, and it's just a good thing to have. Good luck.